Alright, hello everyone, welcome to our lesson today on solving multiple right triangles. So for the past few lessons, we've talked about solving right triangles with all those trig identities. But today, we are using the same ratios or identities to solve multiple triangles at once. Right? So we're going to get something like this. Well, we have two right triangles, mush them together, and we have to figure it out. But to be honest, it's pretty fun. In this example, we want to find the length CD. So if we label that, it is this line right here, right? The line CD. And now we're not really given a lot of things. We know what this length is, right? It's 4.2 centimeters down here, but we don't really know anything else. But what we can do is we can first find what this line is, right? We can find BD first. If we find this line, we can use this same line to find what CD is, right? So it's like a multi-step process. The tricky part of questions like those is to figure out which lines to find and which lines are important, right? So if we want, we could like find this line right here, right? We can find the line AB pretty easily, but it doesn't really give us any more information on how to find the line CD. So with that being said, very quickly, we just have to go over SOHCAHTOA. So SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So now, in this case, we're trying to find this line right here, right? So we have to look at the first triangle. So in this first triangle, this line is the hypotenuse, right? That's like the longest diagonal line of the triangle. And we're also given this angle right here, the 47 degrees. So in order to find this BD line here, we will use sine, right? Because if we use sine, we have this angle, its opposite is 4.2 degrees, over the adjacent, which is the BD, is the one we want to find out. So sine of 47 degrees, make sure you're calculating degrees, is 4.2, that's the opposite. Okay, so 4.2 over the line BD. To find the BD, we multiply everything by BD because we don't like fractions. So BD times the sine of 47 degrees equals to 42, or 4.2. We divide everything by sine 47 degrees to isolate for BD. So 4.2 divided by 47 degrees. This gets us 5.74 degrees, or centimeters, sorry. So this line right here is 5.74 centimeters. Okay, and now with that being said, we can now solve for CD, right? So this line right here is also the hypotenuse for this triangle. And with question CD, or with this angle here, we can find CD because it is adjacent to our 26 degrees angle. And what that means is the cosine of 26 degrees is the hypotenuse, so what we just found, 5.74, over the adjacent, which is CD. Right? So relative to this angle now, this is the hypotenuse, the line we just found, and we want to find CD, which is the adjacent. So similarly, we multiply everything by CD to get rid of any fractions. Okay. And next, we divide both sides by cosine of 46 degrees to isolate for the CD. Then it gets us 6.4 centimeters. Right? The question is asking us to round to the nearest tenth of a centimeter. Our actual answer from the calculator is 6.3863, blah, blah, blah. So we round it to 6.4 centimeters. Right? So that's all there is to it. All we're doing here in those questions is to use the information from another triangle to fill in what we don't know in the other triangle. Okay, so here's a word problem for us. So from the top of a 20 meters building, so we are right here, a surveyor found the angle of elevation. So this right here is the angle of elevation. To the top of the another building is 30 degrees. And the angle of depression, which is this angle right there, angle of depression, right, to the foot of the building is 15 degrees. So we want to find the height of this building right here. And for all word problems, we just have to draw it out. So we already have a pretty nice diagram of it. So we'll just draw out in a triangle to make it a bit cleaner. Right? So we know that those two are right angles. This is 30 degrees and this right here is 15 degrees. And we also know that this length right here is 20 meters. Okay, so this is pretty much all we know. But we want to find out what this big line is. Right? We don't know what x is. So our point of attack is, if we can find out what this segment is, right? If we find out this segment, let's call it segment y, right? If we find out what y is, we can then combine, right? We can just add this 20 meters to this y here to get a total of x. And now, in order to find that, we don't really give anything. All we know from this triangle here is a 90 degrees here and a 30 degrees here. But luckily, we know that from this triangle down here, we are given an angle and a measurement, that's all we need to do to find anything we want. So our game plan now is we can find the length of this line right here. And the moment we find this line, we can use this line and this angle to find y. Alright, so that's our game plan. So let's name this line here z now, and let's figure it out. So from this 15 degrees angle here, we have the opposite, which is 20, over the adjacent, which is the z. So we will use tangent. So the tangent of 15 degrees is the opposite, which is 20 meters, over the adjacent, which is z, which we're going to find out. Okay, so we multiply everything by z, and then we divide everything by tangent of 15 degrees. That gets us 74.64 meters. Okay, so that's what z is. And now, right, if we zoom in on a single triangle here, right, so this is the bottom triangle of this configuration. We got 15 degrees with this angle. We got 20 meters here and 74.64 meters up there. Okay, now moving on to the bigger triangle now. Let's actually do it in a different color. So now with y, right, so let's draw our upper triangle now. With the y here, right, we're trying to find y. We know 30 degrees, which is given by the question. We also know that this bottom part is 74.64 meters, right, because that's what we found from the first part. So what we can do is notice that from this angle, here's the opposite, here's the adjacent. So the tangent of 30 degrees is equal to the opposite, which is y, over the adjacent, which is 74.64. Right? And then we multiply everything by 74.64 to get rid of any pesky fractions and to isolate for y. In a calculator, y equals to 47.09 meters. Okay, so now we know what y is. We know that this 20 degrees down, or 20 meters down here is 20 meters. So all we have to do is add them up. So let's do, once again, let's do in different color. So now in blue, that's the final height of the building here. We're just gonna do 43.9 meters plus 20 meters. That is 63.09 meters. Right? Which means after all of that, the building is just 63.09 meters tall. And that's pretty much how we do it. Or, oh, once again, I forgot to mention the rounding of this question, but we can just leave it at 63 meters, right? Or 63.1 meters. So yeah, that's pretty much it. As a recap, all we did here is we drew out a diagram. We figured out, we want to know this big X here. And to do that, we already have parts of it. We already have the 20 meters of it. We just have to find out what y is. And we noticed that we only know anything about this bottom triangle here. So we found this middle measurement right here. And using the same middle measurement with this angle with the upper triangle, we found this y here. And then we just added up together. Alright, so with that being said, let's do some practice questions. So pause the video here and give it a shot. Okay, I hope you got some chance to go over them, right? So, for our first question here, we want to find jk to the nearest tenth. So here's jk here. And now, with our two triangles, we actually know something about both of those triangles, right? Because we have one angle and one side length for each triangle. We can find anything we want. So our game plan is, with this side length and this angle, we can find the length of jm. And with the same side length and this angle, we can find the length mk. And then we can just add those two side lengths together. Okay, so let's start with JM here. We know that looking at this angle, we have 40 degrees. This adjacent to this 40 degrees is 5 meters, and we want the opposite of that. So we use tangent. So the tangent of 40 degrees is opposite, which is JM, to the adjacent, which is the 5 meters. So we multiply the 5 onto each side to get us the JM. And JM equals to 4.2 meters. Okay, so that's 4.2. We look at this angle now, the 20 degrees. We see the opposite is MK, with the adjacent of 5. So the tangent of 20 degrees is the opposite MK over 5. So 5 times the tangent of 20 is MK. So MK equals to 1.8 meters. 1.8 meters. Okay, so now we got both of those. All we have to do is to add them up. So 4.2 plus 1.8 very conveniently gets us to 6 meters. Alright, so this whole length of JK is just 6 meters. Okay, so now next question. Okay, we want the angle XYZ. So we want this angle right here. We are given this side length, and we're given this side length. Alright, and because this is a line straight down the middle, we can conclude that this angle right here is also 90 degrees. Okay, so now what we can do is we can find this angle right here, right, using sine, because we have the line that's opposite to it and the hypotenuse right here. And now for this line right here, we only have one measurement. So what we can do is to find the length of this line right here. So then we can use this line and this line to find the angle of this one. And lastly, we'll add those two angles together of the two triangles. Alright, so let's put that into practice here. Let's try to find this small angle right here first. So we have the sine of, in this case, this angle will be VYZ. Right? Because this is the angle that connects the dot from V to the Y to the Z. It's this angle right here. So the VYZ is 8, which is opposite to it, over 10. And so, the angle sign. So the angle of VYZ is just the inverse sine of 8 over 10, which is 53.13 degrees. Okay, so that's 53.13. And now for the other one, right, for this angle now, we have to first find the length of this line first. So with that, we can use our buddy Pythagoras here. So with the Pythagoras theorem of this triangle right here, we have c squared plus a squared plus equals to a squared plus b squared. The c squared is the hypotenuse, which is 10 squared, plus a squared, which is 8 squared, plus b squared. That's the length we don't know. So it's 100 equals to 64 plus b squared. B squared equals 236. And all we have to do is to square root both sides. So b is 6. So this side length in the middle is 6 centimeters. And with that, all we have to do is to find the ratio. So find a ratio where we can reach the angle. And for this angle, which is perspective to this angle here, we see the opposite is 17 degrees, or 17 centimeters. And the line that's adjacent to is 6 centimeters. Which means that we can use tangent to find the angle of VYX. Okay, so the angle of from the V to the Y to the X right here, this angle. The opposite is 17 centimeters. And the adjacent is 6 centimeters. Okay, so we just inverse tangent that to get 17 over 6 to get 70.56 degrees. And now for our very, very last step, we'll add those two angles together. So 70.56 degrees plus 53.13 degrees. That gets us 123.7 degrees round to 10th. Okay, so there we go. And now lastly, here's a word problem. So we got a tower with two wires supporting it. both attached to the same point, and I want to find out how far apart are the wires. So we're trying to find out this distance right here. And we can import that, I guess, into a diagram. So it looks something like that, where this whole angle together is 60 degrees. Want to find out what x is. We got a 10 meters here and an 8 meters here, and a right angle right there. Okay, so our game plan now is we have this big triangle here that's 60 degrees and 10 meters of the hypotenuse. We can find the big length, so the total length here, which is y. And we can subtract that by this length here, which is z. Right? So x is just y minus z. And now in order to do that, okay, so first of all, we can take this triangle to find the y. We know that we have an angle of 60 here with a hypotenuse of 10. So, and then the y here is the opposite. So we'll use sine in this case. So sine of 60 is the opposite, which is y, over the hypotenuse, which is 10. And to find the y, we just multiply 10 to the sine of 60 to get 8.66 meters. Right? Or actually, let's just do this in a different color. Okay, different color, same answer, 8.6 meters. So that's how tall this entire tower is. Now let's find z. With z, we can't really directly find it because we're only given the angle of this big triangle here. Right? That's not the angle of the small triangle. We want to find the angle of the small triangle. Right? But here's what we can do. We know that this line right here is 8.66, right? As we calculated. So with the Pythagoras theorem, we can find the base of this triangle here, right? Because we noticed that the base of both triangles share the same line. So, oh god, I'm all colors. Let's do red here. So red right here, this is, let's say like A, for example. And y is 8.66. Right? So with A, we know that the c squared equals to a squared plus b squared. Right? We know the hypotenuse is 10 meters. We're trying to find the a squared plus the b squared, which is the y, so 8.66. Okay? So a squared equals to 10 squared minus 8.66 squared. Into calculator, we get 25.004. Oh, 0044. Okay? So now we just square root all of that. So a is just 5. Right? So the base of both triangles is 5 meters. Okay, which means that with z, we can just do another Pythagoras. Right? So c squared equals a squared plus b squared. Because now with z, right, with this little triangle now, we have the hypotenuse, which is 8, and one of the length was 5. So we have 8 squared equals to 5 squared plus z squared. So z squared is a squared minus 5 squared, which is 64 minus 25, 39. And 39 square rooted would be 6.24 meters. Okay, so now we know the z as well as 6.24 meters, which means that the x is just the 8.66 minus the 6.24, which gets us 2.42 meters. Oh my gosh, we finally did it. Right? So as you can see, it's a lot of steps, but honestly, that's kind of the fun part. Right? So not only are we using trig ratios, we're also just kind of using logic and reasoning to figure out what do we add, what do we subtract, that kind of stuff. Right? So yeah, with that being said, keep practicing and stay hydrated.